Hey everyone, it's Mrs. Hinckley. In this lesson, we are multiplying and dividing rational expressions. So remember, a rational expression is just a fraction whose numerator and denominator are made up of polynomials. And we can figure out the domain because it's everything except for the x's that make the denominator 0. So let's look at simplifying rational expressions. We consider them simplified as long as the numerator and denominator have no more common factors. Meaning if I have something like AC over BC, I can cancel out those C's because C divided by C is 1, and I'll just be left with A over B as my simplified answer. Now suppose we had a rational expression that looked like A plus C over B plus C. Could we just cross off the C's like this and call it a day and say the answer is A over B? No, this is something I like to call puppy murder. Yeah, it's terrible. I know, horrible. You never want to do it. Who wants to kill a cute little puppy? So please don't ever make this mistake. You cannot cancel out terms when you're adding or subtracting, only when you're multiplying. So let's simplify some of these rational expressions. Basic fraction, 15 over 65. You guys know how to simplify this. We're going to first factor it into 5 times 3 in the numerator. And then in the denominator, think about the factors for 65. Well, that's also divisible by 5, and it would be 5 times 13. So they share a common factor of 5, which means you can cancel them out. 5 divided by 5 is 1, leaving me with the simplified expression of 3 over 13. Okay, let's take a look at this next one. We have 2 common factors of x plus 3. Those are going to cross out because x plus 3 divided by x plus 3 is just 1. So our simplified rational expression is 4 over x minus 3. Now if I have 4 plus x plus 3 divided by the quantity x plus 3 times x minus 3, can I cross off the x plus 3's here? The answer is no. Again, so sad. Please don't do this. Let's take a look at the next one. Can I cancel out the x squareds and just say the answer is 7x? What do you think? No, we cannot because you're adding here. This is a sum. More puppy murder has been committed. Let's take care of this properly. You have to first factor. Factor out a common x, and you're left with x times x plus 7 over x squared. Now, because we're just multiplying and dividing, we're not adding or subtracting these quantities, you can cancel out one pair of x's, and you're left with x plus 7 over x. This is the correct way to handle simplifying these expressions. Okay, let's start by multiplying two rational expressions together. You know that if you multiply two fractions together, you simply multiply the numerators and multiply the denominators straight across. Same thing is true for these rational expressions of polynomials. So we're going to go ahead and start by factoring. This is your ticket. You're going to factor the numerator, factor the denominator, and then we can see if anything in the numerator cancels with anything in the denominator. So for this first expression, we factor out a common 3x in the numerator, and then we factor that quadratic as x plus 5 times x minus 1. For the second expression that I'm multiplying by, that quadratic factors into x plus 5 times x minus 4, and the denominator is just 3x. Notice if we're multiplying, you just multiply the numerators straight across the top, and you multiply the denominators straight across the bottom. So now any numerator that matches any denominator, we can go ahead and cancel that out. So I have 3x over 3x, x plus 5 over x plus 5, and then I notice something interesting. I've got this 1 minus x and this x minus 1, and they look pretty similar, but their signs are opposite. So what we're going to do is take a negative 1 out of that numerator expression so that we can flip all the signs. If we flip all the signs, it's now going to be x minus 1, and it will match the denominator quantity of x minus 1. So from here, we can go ahead and cancel out x minus 1 divided by x minus 1. So our simplified answer here after multiplying is simply negative 1 times x minus 4. And of course you could distribute that negative if you wanted, and you would have negative x plus 4. All right, we're just going to do one more example in this video where we're dividing rational expressions. This rule is the same as when you're dividing fractions with numerical values. All you do is flip the second rational expression and you multiply instead of dividing. So let's see how this would work. With this rational expression, 7x over 2x minus 10, I leave it as is, and then I flip the second one, and we multiply. So now that I've flipped that second one, I'm going to factor. It's my golden ticket again. Anything that factors, take care of it. So that denominator has a common factor of 2. I'm going to go ahead and write that as 2 times x minus 5. In the second rational expression, that numerator there can be factored. It's a quadratic. You can factor that into x minus 5, x minus 6, and that denominator has a common factor of x. So now that we've factored everything, we're going to look and see what can cancel between the numerator and the denominator. I see I have a pair of x's. X divided by x can work. X minus 5 and x minus 6. When I cancel out all of these pairs, all we're left with is 7 over 2. So that big, long, nasty division problem leaves you with just 7 over 2. That's pretty much it. In a nutshell, this is how to multiply and divide rational expressions. Please remember not to kill any puppies. Let's keep them happy and alive. Thanks.